So let's look at some rules for significant figures when we're adding and subtracting, or multiplying and dividing. When we're adding and subtracting numbers, it isn't really about significant figures. Instead, we look at the number of digits after the decimal. Okay? Just the digits after the decimal. This one has none. Okay? So for instance, this 12.36 plus 2.4, right? My calculator, or my brain, would tell me this is 14.76, but this only has one number after the digit after the decimal, and this has two. So our answer can have no more than the one with the fewest digits after the decimal point. So I find the one with the fewest digits, and that's what my answer needs to have. Okay? So that would be the answer to this. So 12.36 has two digits after the decimal, 2.4 has one, so my answer can have one. 1.003 plus 34 is going to give me 35.003. 34 has no digits after the decimal. This has 3, so my answer can have no digits after the decimal. So my answer is just 35. My answer can't be any more precise than my least precise measurement. Okay, so here we've got 512.002. Again, no digits after the decimal, 3 digits after the decimal, so my answer is going to be 512. Okay, 34.5 minus 17 is 17.5. 1 digit after the decimal, no digits, so I actually have to round this up to 18. My final answer can't be any more precise than my least precise measurement. So this is going to look similar for multiplication and division, but instead of looking at digits after the decimal, we look at our significant figures. Okay, our answer can have no more sig figs than the measurement with the fewest sig figs. So 23.4 has 3, 0.1 has 1, okay, so this is going to come out to be 2.34, but I can only write it with one sig fig, so my answer is actually just 2. Seems like it's a lot of rounding off, but my answer can't be any more precise than my least precise measurement. Okay, when I multiply this out, I get 408,072 according to my calculator, but I need to round that off to, let's see, this has 5 sig figs and this has 2. I need to round it off to 2 sig figs. So I would have to record this answer as 410. 800 divided by this 15 comes out. My calculator gives me all sorts of numbers. It goes 3, 3, 3, 3, 3. Okay? But we're not going to write all those numbers. We're going to look and say, this has 1 sig fig, and this has 5. So my answer can actually only have one significant figure. I'm going to have to write this as 50. Okay? But what if I put a decimal after that 800? Now it has 3. And this has 3, so my answer can have 3. So I can write it as 53.3 because my measurements were more precise. What if we have a combination of both multiplication and addition, or multiplication and, division and addition? So we're going to have to take it one piece at a time. So for instance, I would look at this and I would say it's 23.4 plus, I'm going to multiply this out, okay, and I'm going to round it off. I'm multiplying, so I'm going to look at sig figs. There's 3 here, more than 3 here, so my answer has 3. Now when I add these, I look at digits after the decimal. They both have 1, so my answer becomes 33.4. So you'll see that I applied both rules one at a time. Okay, again, I'm going to go ahead and multiply these numbers first. I've got 100 plus, when I multiply this out, I'm going to round it off to 14 because I've got 2 sig figs and 2 sig figs. And now when I add them, there's no digits after the decimal, so I get 114. So that's my final answer there. Here, 2.3 plus 8.09, that equals 10.309 according to my calculator, but I can only have one digit after the decimal. So I'm going to change that to 10.3. And then I'm going to divide the 10.3 by 1501. And my calculator is going to tell me it's 0.006868. Okay, so how many sig figs can I have? Well, that has 3, and that has 4, so my answer can have 3. So 0.00687. So those are your rules for adding and subtracting and multiplying, division, and using sig figs.